Assalamualaikum and a very good evening to my fellow viewers. Today I'm going to do a presentation for my assignment in CHM083. The topic I chose for my assignment is green chemistry. So what is green chemistry? Let's find out. Green chemistry, or also known as sustainable chemistry, is a field dedicated to designing chemical products and processes that reduce or eliminate the use and generation of hazardous substances. It emphasizes waste prevention, the creation of safer chemicals, the use of renewable feedstocks, energy efficiency, and the design of degradable products. By focusing on these principles, green chemistry aims to minimize the environmental and health impacts associated with chemical manufacturing. This approach not only addresses critical environmental concerns but also drives innovation towards more sustainable, efficient industrial practices. Moving on, we have objectives of green chemistry. So let's go through one by one. The first one is prevent waste. Design processes to minimize the generation of waste, thereby reducing the need for waste treatment and disposal. Second, creating safer chemicals, developing chemical products that are effective for their intended purpose but have reduced toxicity to humans and the environment. Moving on, we use renewable feedstocks. By this, we utilize raw materials that are renewable rather than depleting finite resources such as petroleum. Moreover, we have improved energy efficiency. Design processes that consume less energy, often through the use of catalysts or milder reaction conditions, to reduce energy consumption and greenhouse gas emissions. Greenhouse gas emissions will affect the the ozone layer of our planet, that can cause more heat waves to come into our planet. That mainly is the cause of global warming. So we do not want that. Alright, moving on, we have design for degradation. This, we create chemical products that break down into harmless substances after use, preventing persistence and accumulation in the environment. And lastly, we have reduced derivatives. By this, we minimize the use of auxiliary substances and derivatives which can create additional waste and complicate processes. Moving on to the next subtopic, we have the 12 principles in green chemistry. So what is green chemistry? What is the 12 principles in green chemistry? So basically, the 12 principles of green chemistry serve as a guiding framework for designing chemical processes and products that minimize environmental impact while maximizing efficiency and sustainability. So let's go one by one. Number one, we have prevention. Prevention, it is better to prevent waste than to treat or clean up waste after it is formed. This principle encourages the design of processes that generate minimal waste. Second, we have atom economy. This is synthetic methods should be designed to maximize the incorporation of all materials used in the process in the final product, minimizing the use of raw materials and reducing waste. Moving on, we have less hazardous chemical synthesis. Wherever possible, synthetic methods should be designed to use and generate substances that possess little or no toxicity to human health and the environment. Next, we have designing safer chemicals. Chemical products should be designed to achieve their desired function while minimizing toxicity. This principle promotes the use of substances with little or no toxicity. And we have safer solvents and auxiliaries. The use of auxiliary substances, example solvents, separation agents, should be made unnecessary wherever possible, and when used, should be innocuous. Moving on, we have design for energy efficiency. Energy requirements of chemical processes should be recognized in the environmental and economic impacts and should be minimized. Ideally, processes should be conducted at ambient temperature and pressure. Next, we have use of renewable feedstocks. A raw material a raw material or feedstock should be renewable rather than depleting whenever technically economically practicable. Other than that, we have reduced derivatives. Unnecessary derivation such as use of blocking groups, protection slash deprotection, temporary modification of physical or chemical processes should be minimized or avoided if possible because such steps require additional reagents and can generate waste products that can cause environmental harm. Moving on, we have catalysts. Catalytic reagents such as selective as possible are superior to stoichiometric reagents. Catalytic amounts of substances are used in many processes and are not consumed in stoichiometric amounts. Moving on, we have design for degradation. Chemical products should be designed so that at the end of their function, they break down into innocuous degradation products and do not persist in the environment. Real-time analysis for pollution prevention. Analytical methodologies need to be further developed to allow for real-time in-process monitoring of control prior to the formation of hazardous substances. And last but not least, we have inherently safer chemistry for accident prevention. Substances in the form of a substance used in a chemical process should be chosen to minimize the potential for chemical accidents, including releases, explosion, and fires. So basically, these principles were developed by chemists Paul Anastas and John Warner in 1998. These outline a vision for sustainable chemistry that aims to protect human health and the environment while fostering innovation and economic growth. By integrating these principles into chemical research, development, and production, we can move towards a future where chemistry contributes positively to the human health and our environment. Alright, moving on. We have applications of green chemistry. So one of them are like energy, electronics, pharmaceutical mostly into our medicine, consumer products. Nowadays, everybody likes to buy stuff that has a lot of the products that humans use today are containing a lot of chemicals that may contain harm to the environment and to the human health. So we derive to create more safer products for us to use. And we have automotive, textiles, and food industry. Moving on, we have the challenges in adopting green chemistry. So one of them is initial cost and investment. The adoption of green chemistry often involves initial costs and investments that can pose challenges to businesses and industries. Transitioning from traditional chemical processes to greener alternatives typically requires capital for research and development, technology upgrades, and retaining of personnel. Mostly, while the initial investment in green chemistry may present challenges, it represents a proactive step towards sustainable development and resilience. Moving on, we have another challenges is mindset shift. So mindset shift. The adoption of green chemistry necessitates a significant mindset shift within the scientific community, industries, and society at large. Unlike traditional chemical practices, green chemistry prioritizes sustainability and environmental stewardship throughout the entire life cycle of products and processes. So adopting green chemistry requires a collective mindset. So adopting green chemistry requires a collective mind shift towards viewing environmental sustainability as integral to scientific progress and industrial success. By embracing this shift, we pave the way for cleaner, safer, and more sustainable chemical practices that benefit both the people and the environment. Moving on, we have education and awareness. So basically, education and awareness play pivotal roles in adopting an investment of green chemistry. At its core, green chemistry aims to minimize environmental impact while maximizing efficiency and sustainability across industries. Achieving this goal hinges on educating future chemists, engineers, policymakers, and consumers about the principles and benefits of green chemistry. In conclusion, education and awareness initiatives are essential catalysts for accelerating the adoption of green chemistry practices worldwide. But during this time, people we are not doing our job to spread awareness about the importance of having green chemistry for our future, because it will it will help us create a better environment, a safer place for us to live. So moving on, we have regularity and policy barriers. So adopting green chemistry faces regularity and policy barriers that can hinder progresses towards more sustainable practices. While green chemistry offers significant environmental and economic benefits, navigating existing regularity frameworks designed around traditional processes present challenges. One of them is the approval processes for new chemicals and technologies. Regulatory agencies often require extensive testing and documentation to ensure the safety and efficiency of new products. These processes can be costly and time consuming, particularly for innovative green chemistry solutions that may not fit neatly into existing categories or testing protocols. So, in conclusion, while regulatory and policy barriers present challenges, they also represent opportunities and constructive dialogue and reform. By promoting transparency and encouraging innovation and aligning incentives with environmental goals, policymakers can pave the way for widespread adoption of green chemistry, driving positive environmental outcomes and economic growth. Moving on, we have compatibility with existing infrastructure. Green chemistry, while promising significant environmental benefits, faces challenges with its own compatibility with existing infrastructures. Many industries and facilities are designed around conventional chemical processes that prioritize efficiency and cost effectiveness over sustainability. One major challenge in this topic is that is retrofitting existing manufacturing plants to accommodate green chemistry practices. This often requires such substantial investments in new equipment, technologies, and processes designed to minimize waste. In processes designed to minimize waste, use safer chemicals, and reduce energy consumption. Integrating these changes without disrupting ongoing operations can be complex and costly. So it relates to initial cost and investment. While the benefits of green chemistry are clear, overcoming the challenges of compatibility with existing infrastructure and requires collaboration, innovation, and strategic planning. By addressing these challenges proactively and investing in infrastructure upgrades, industries can pave the way for a more sustainable future. Last but not least, we have scaling up sustainable technologies. Scaling up sustainable technologies in green chemistry presents several challenges despite their potential benefits. Initially, technologies that demonstrate sustainability at a small scale may encounter difficulties when expanded to industrial levels. This transition requires significant investment in infrastructure, equipment, and processes tailored to handle larger volumes efficiently. Moving on, so that is all for my presentation today. In conclusion, Green chemistry represents a transformative approach to chemical science, aiming to create safer, more sustainable processes and products. By emphasizing waste prevention, renewable resources, and efficiency, and the design not only addresses environmental and health concerns but also fosters innovation and efficiency. Its widespread adoption across various industries holds the promise of significantly reducing the ecological footprint of chemical practices, ultimately contributing to a healthier planet and a more sustainable future for us to live in peacefully. So that's all for my presentation today. I hope you guys enjoy it, and I see you next time. Bye bye.